Okay, I thought I would just do a quick explanation video of the ABUS Touch 57 bypass that I demonstrated a couple of days ago. I'll drop a link to that video in the comments. Yeah, the house was fairly loud while I was recording that, so I had to mute the audio, but I figured I'd do another video and just kind of explain like why that works and what was going on. So this is the lock that we used in that video, which does still work. And I'll pull this one apart in a minute and just kind of go through it a little bit. But yeah, this is the one that was used in the last video, and it's stock basically, apart from having been taken apart once when I gutted it on film. But this is the one I was kind of using to develop that bypass. So this is why I took the shackle screw out of this one before I started messing with it. So there's, and I'll show you on the board in a minute, but inside here obviously is the actuator, and then the board has a sensor on it which sees where the actuator is, like what position it's in. And if you get that in the wrong place when you reassemble it, it won't turn the actuator anymore. The board thinks the lock is already open, so it doesn't supply any more power to the motor. And yeah, if you put it back together with the shackle screw in and get that wrong, you end up with a lock that doesn't work anymore. And then yeah, I had to cut the shackle off this and then basically drill out the ball bearing that sits in there, which is here. This is the ball bearing that was keeping that locked. And then yeah, obviously made quite a mess of that. Managed to get the screw out anyway, which that lets you pull the core of the lock out, which again we'll show you in a minute. And there's another retaining screw that would live in here. So in its state like this, there's a screw at the top and a screw at the bottom. Obviously you can take this bottom panel off while the lock is locked. It's only a screw to let you get access to the battery compartment. But yeah, you can't take the lock apart without that shackle screw, but it doesn't do anything other than retain this core, which yeah, I took it out of this one in case I bricked another one of these while I was demonstrating the bypass on the film. So you can also see how I've kind of made this into a cutaway in the loosest possible sense of the word. I basically drilled a couple of holes in the front just to sort of show this board. So this is why and how this bypass works. Just closer to the camera. So obviously you can take this bottom piece off, and then you have access to this while the lock is still locked. There's no battery in here now, but normally the battery would be in here. And there is just enough space between like the body and this core for you to get a piece of shim material in there. So this is 0.13 mil or 0.005 inches. It's a piece of feeler gauge out of a cheap like Amazon set of feeler gauges. But if you look at the board that you can see underneath here, obviously you've got this weather seal which is held in place by the lock, and it's not glued to the board, but it is attached to it unless you take it off. And then underneath there, there's these 4 contacts. So these go into a block under here. 2 of these on the left are power to the board. So when the battery's in place, you can put a multimeter across those, and it's got the 3 volts coming out of the cell that's in here. And they're labelled B plus and B minus. And then you've got these 2, which are labelled M plus and M minus, and these are the power to the motor. So the motor sits kind of here, which again we'll see when I pull the core out. All the sort of fancy electronics is actually on the back of the board, so the sensor sits on the front and a couple of LEDs for around the ring light and stuff. And then yeah, there's some header pins which are through soldered, and that's the sort of weakness here that we're exploiting. So you can take a piece of this shim, the feeler gauge. This is wrapped in sellotape. Obviously the lock housing is conductive, as is this piece, which is why in the bypass video you can see me just doing a continuity check on the 2 what I call probes as they're going in. Obviously if they're touching or the insulation isn't right, then you'll just short the battery when you put power across them, and that's not a good thing. Yeah, so you can just slide these underneath, and if you get it in the right spot, you can get it to touch that contact. So you can see it's kind of on that contact now. And then you just take another one, slide it in the other side. And you have to give it a bit of a wiggle to get it kind of underneath that that weather shielding. And yeah, you can see those are on the contacts now. So if I leave that there, I will just do a continuity check before I set fire to something. That one. So these should not, yeah, there we go, they should be fine. And then hopefully if I put some power on this because this lock has been opened a couple of times, you might just need to put some pressure on the contacts to keep them in place. This is just 2 AA cells, which gives you your 3 volt out. Yeah, I'm gonna have to just put a little bit of pressure on those, maybe just adjust them a little bit. It is a little bit fiddly to get the probes into the right place. You need to get them right on those contacts. And again, because this is a cutaway, they kind of don't have that like pressure helping them. Let's see if we can just put some pressure on there. Hold those in place. This is where it gets fiddly when you've only got 2 hands and you need to hold all these different bits together. But there you go. So you can hear the motor turning, hopefully, and see it. So that's how this works. You're basically just applying some voltage to these pieces of feeler gauge, and it's supplying power directly to the motor. So obviously the board doesn't have power at this point, so the chips on there aren't powered up. The fingerprint reader doesn't work. You're bypassing all that circuitry completely, and it's completely non-destructive. So yeah, this is the one that I showed in the last video. It still works just fine. Obviously this was done for R&D purposes. I wasn't intending to brick this and have to take it to bits, but here we are. So let's take the bottom of this lock out and show you the board and yeah, show you why this works. So to get these apart, obviously you take this screw out and this screw out, take the bottom plate off, and then you just kind of need to find something just to wiggle around in this hole. This one does cause a little bit of damage if you do it too many times anyway. I've had this one apart quite a few times, so it's got a bit of damage to it. Yeah, this one is fine inside. And then once that slides out, you can just take this piece out, and then the board and the weather housing are still inside the lock. So we can take those out. There's the board, there's the weather seal. Normally this is attached to the board. Because I've taken this off once, it no longer is stuck to the board, but it is still, it does the job, right? And you can see it covers those contacts. Let's just have a look at this piece. This has the motor in it, and this is my fin tweezers. This is that block. You can see the circuit board sits in. I'll put that back in place in a minute. So yeah, power comes off the battery and goes to these two, the 2 on the left and then the 2 on the right are connected to the motor. The board itself, here are the chips, so we can get that to focus. Yeah, you're not going to be able to read the part numbers on there on this video, sadly, but I might throw a close-up picture of those on an Imager link or something like that. But this is the side that would be exposed anyway, so that slots into there. And then I have a battery here somewhere. There we go. Put the battery in. You can see it still works. So yeah, it still reads my fingerprint. And if we were to do that with the battery, and you'd see these 2 pins on the left. the one labelled B plus and B minus, they have power when the battery is in there. But it's these two that we're interested in. So this is, again, I'm not going to show this because it's a pain to do it with like two hands and also trying to do it on video, but if you put a power source in there, put the multimeter across these two pins, you'll see it like spike to 3 volts while the motor actuates when you read a fingerprint. So that's how it's driving the board. However, if we take our power again, we can just, again, there's no battery in this right now. We can just apply power directly to those, and hopefully you can see, pop that up so you can see it a little bit better. If you watch the motor, you can see it move, and then if you reverse the polarity on this, it will turn the other way. We only need it to turn one way to pop the lock, which is fine. So that's how this bypass works anyway. It's the only design fault really on this lock that I've found so far. Obviously you can get that probe from the bottom of the lock up to various components on here. Like it will fit all the way, but these don't really do anything. I'm not even bothered to see what they do. I don't know if they're test points or something else, but you could get to them, but yeah, it doesn't do anything easily anyway, and there might be something else there to look into, but because this is a through-hole component, you can just get something onto the solder pads, apply power directly to it, and that will trigger the motor, which will turn the actuator, which will open the lock. So yeah, that's how this works. And yeah, this little switch here, it's kind of hard to see, but this is what engages with the actuator inside the lock. So it tells the board where the actuator is. So the board then knows whether the lock is open or not, and if you don't get that in the right place when you reassemble this, the board will think the lock is open even though it's not, and you'll put your fingerprint on and nothing will happen, and then if you put the shackle screw in like I did, you brick the lock, which is, yeah, a bit of a pain. So yeah, that's why I took the shackle screw out of this one before I recorded the actual bypass video. The marks on here are just, yeah, to help me line up where the probes need to go when I was doing it blind, but you could build a proof of concept of this on one of these, just mark it roughly, which is what you saw me do in the other video. And then you just unscrew the base plate, put that in position, mark the spots, and then I've also marked the rough depths on the probe just with some Sharpie, and then you just have to play around a couple of times, but with practice you can get it down to within, sort of 30 seconds or so. But yeah, that's how this bypass works. Hopefully, yeah, it makes it a little bit more clear what was going on in the other video, and yeah, if you've not seen that, I will drop a link to it in the description below. Yeah.